All right, guys, in this video, we are going to talk about, before we can really get into it, let's just practice a few things. So the first part of this warm-up here is simplifying radicals. The first examples here actually is not even simplifying, it's actually just evaluate just to see what we remember about perfect powers. So the first one here is the square root of 16. Remember, if there's no number in the pocket, it's almost as if there's a 2 there. So the square root of 16 is just 4. Number 2 here is the cube root of 8, and that is 2, because 2 times 2 times 2 is 8. Cube root of 27 is 3, because 3 times 3 times 3 is 27. And then this one, the difference between the first one and the last one here is the fact that I have a 4 in the pocket here. So the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. All right, so a rational exponent. Rational is just another word for fractional. And a fractional exponent, I'll just give you an example. We're going to have some base, we'll call it x, the n over d. I'm using n and d here for numerator and denominator. The top number is the power, and the bottom number is the root. So we could actually view this as the d root. So like we'll have a numerical value there for n and d, but it would be the d root, dth root of x to the n. Or equivalent could be the dth root of x all raised to the n. So both of those are acceptable. So a mnemonic device that I've used to kind of help remember that is a picture of a flower. All right, so if I think about a picture of a flower, all right, we got the stem, it hits the ground, look at our leaves, right? And this horizon line here is like our fraction bar, and underneath, you know, the flower gets its water from the roots, right? So the roots are on the bottom, and the flower power, there's a nice 60s term for you, flower power, is on the top. So if I wanted to evaluate these examples here, 9 to the 3 halves, we could do it using mental math. But I'll just show you the work behind it. So we have 9 to the 3 halves. So the first thing that we want to do, and honestly the easiest thing we can do, is actually work with the root first. So the root is 2. So I'm going to do the square root of 9 and then cube my answer at the end. Doing the root first actually gives us smaller numbers to work with, but it doesn't matter if you go in either order. But the square root of 9 is 3. And so then 3 to the third is 27. 32 to the 2/5. Again, if I do the root first, right, the root is the 5, that's the number at the bottom. So we have 32, sorry, not 35, 32, 5th root of that. And then I'm going to square it. So the 5th root of 32 is 2, and then squared is 4. So my final answer for this one is 4. Final answer for the one before was 27. We'll just do one more together, and then I'll have you guys practice a few of these in a minute. So 16 to the 3 halves. In my head now, I'm just going to say, okay, the root is 2, so I'm doing square root. Square root of 16 is 4. 4 cubed is 64. Okay, so just a little bit of practice with the mental math there, but you could also do these. So why don't you go ahead, if you want, to pause the video and try D, E, and F on your own, and then then I will share the work for that. I wanted to show you guys that this can also be done on a calculator. Obviously, if I wanted to know how to do roots, like if I wanted to do, let's say the one example 4 is 64 to the 2/3, we might recognize that that's really the cube root of 64 to, and that's 4, and then that answer squared is 16, but I could actually all in one step actually do fractional exponents here. So if I type in 64 and then hit the little caret button here for the exponent, and then literally type in 2 divided by 3 for the exponent, I can get the answer done for me. So it's still good practice to do these without a calculator, but if not, there's always that as our fallback. So here I've got some answers for you. So 64 to the 2/3 we just did on the calculator was 16. 4th root of 16 squared is 4. And then this one, don't be thrown off by a fraction. If I have a fraction to a power, I could actually raise the top and bottom to that power. The nice thing about having 1 in there, 1 to any power, even if it's a fractional exponent, is still 1. So the top is still 1. And the bottom, we just did in example 4 there, sorry, example D, is 16. So it's 1 over 16 is my final answer. We could also estimate these examples here with a calculator. So 4th root of 5 cubed, I could just type it in that way, or I could actually recognize, well, it can be rewritten as a fractional exponent where the power is 3, so that's the numerator, and the root is 4. So I get the same answer if I type this into the calculator either way. So if I do 5 to the 3/4, I get that. Or if I do the 4th root of 5 and then cube it, I get the same answer. So knowing how to switch back and forth will be beneficial. It'll save us some time as well for these questions. All right, so why don't you go ahead and see if you could do the next one, and then I'm going to switch to the next page. All right, so here are the answers I got by typing these into the calculator. So on the next page, we're going to practice this a little bit more with variables. All we're doing on this page here is rewriting them as fractional exponents. So the first example we have in example 4 here are rewriting as a rational exponent. So you can see in the first example, we have the square root of a. So the power on the a is a 1. It's implied as a 1, but the root, again, this is kind of that time in math where the invisible number that's not there is a 2. So we're actually going to rewrite this as a to the 1/2. And the next one as a to the 1/3. And the next one as a to the 1/4. And the last one here as a to the 1/6. So if you want to go ahead and pause the video and then see if you can figure out how to answer example 5 questions. So here are my answers. As you can see, for E and F, E in particular had a parentheses, so I could write it that way. F, I didn't have parentheses, so I could write it this way. Where you need to be careful is recognizing that the only thing that has the exponent in this example is the Z. So when two things are next to each other without parentheses, the exponent only attaches to the thing that's immediately to its left. So that'd be this guy right here. So technically in example E, I could have expanded this a little bit further and called this x to the 5/2, y to the 5/2. If you didn't though, it's not a big deal. So both of these are acceptable. And technically for F, you could have, if you wanted to, put the Z in a parentheses as well. So for example 6, now we're going to go the opposite direction. I'll do the first 3 and then let you guys try the next 2. So example A, we have a to x to the 3/4. So it's the 4th root of x cubed, or I could write it as the 4th root of x and then the cubed on the outside like that. So I guess the parentheses weren't necessary in this first top example. B, 5th root of x to the 6th. And then C, the only thing getting raised to the 1/2 is the x. At 5 might look like it's getting raised to the 1/2, but it's not. So really this is going to be 5 square root of x. the only thing there getting raised to the x. If there were parentheses, then both the 5 and the x, just like example D here. So that's the difference. For example, D and E, those have parentheses. So go ahead and pause the video, and then I'll give you the answers for these. Okay, so example D would have been the square root of 5x with the 5 underneath, and example E would have been the cube root of xz. Now again, we have to make sure that these are together, getting raised to the 4th power. So you also could have written this one as the cube root of x to the 4th, z to the 4th. Because again, both of those things in the parentheses, for example, E there, are getting raised to the 4/3 power. All right, so that's going to be where I stop this video. So hopefully this should be enough for you guys to come in prepared the next day.